Alright, so I think this is recording. Let's take a look at graphing these trig functions. And we went through in class how to graph the sine curve, and here it's the cosine curve. So as I go around that unit circle, I want the x coordinate at each point. So when the angle is 0 radians, you're at 1, 0, so the x coordinate is 1. At pi over 6, the x coordinate is radical 3 over 2, and the y coordinate is 1/2. Here, both x and y are radical 2 over 2, and at pi over 3, the x coordinate is 1/2. So we see these numbers again through this chart using symmetry. Only now up here at pi over 2, you're on the y-axis and you haven't moved left or right, so x is 0. At 2 pi over 3, I'm in quadrant 2, so now it's negative, and it's going to be the same as negative 1/2. And at 3 pi over 4, it's the same in magnitude as the radical 2 over 2, only it's negative. And at 5 pi over 6, it has the same magnitude as the pi over 6, only it's negative. At pi, at 180 degrees, I'm over to the left at the point -1, 0. The x coordinate's -1. At 7 pi over 6, I'm down in quadrant 3 where x and y are both negative. And at 7 pi over 6, the x coordinate should be negative radical 3 over 2. And then this is negative radical 2 over 2. And then at 4 pi over 3, I should be at a negative 1/2. And at 3 pi over 2, or 270 degrees, the x, you haven't moved left or right, you're on the y-axis, so x is 0. At 5 pi over 3, I'm back in quadrants 4, and in quadrants 1 and 4, the cosine is positive, and at 5 pi over 3, the x coordinate is 1/2, and the y coordinate's radical 3 over 2. This is radical 2 over 2, and the x coordinate at 11 pi over 6 is radical 3 over 2 because the y coordinate's 1/2. And here at 2 pi, I've made one complete revolution, so I'm back to a coterminal angle with respect to 0 radians. 2 pi radians and 0 radians are coterminal, so they're going to have the same point on the terminal side of the ray. So that's a 1. All right, so let's see. I'm going to pause this for a second, get a drink. I'll be right back. All right, I'm back. I didn't want to cough in the microphone. Let's get a decimal approximation for radical 3 over 2 and for square root 2 over 2. I'll put it 2 decimals, even though I won't be able to go really any better than 1 decimal. If I have the square root of 3 divided by 2, 0.87, so real close to 0.9, and square root 2 over 2, 0.7 something, probably. .71. So that's just going to be an approximation. I'm just going to have to eyeball it. So when x is 0, y is 1, so I'm passing through here. At pi over 6, I'm between 0 and pi over 4. Say I'm right here. And at radical 3 over 2, 0.87, I don't know, say I'm right there. At pi over 2, radical 2 over 2 is about 0.7. There, maybe I went too low on that one. Maybe 0.9 is up higher here. 0.8 for pi over 4 at 0.71. You see, here's the bad thing about doing it by hand, that I'm just estimating this to be, half the distance, and 0.7 slightly above that. Pi over 2 is 0. Now that point's easy for me to graph. At 2 pi over 3, I'm between pi over 2 and 3 pi over 4. So this is a negative 1/2, so I don't know, maybe I'm right there. And at 3 pi over 4, maybe I'm here, because at negative right at 0.71, so this was 1/2. This, because the 1/2 is easy in decimal form, that's 0.5. At pi, I'm at -1. Then at 7 pi over 6, I'm again about 0.87. At 5 pi over 4, about 0.71. 3 pi over 2, I'm back up to 0. And now I'm above here, so I'm the same as this guy. And this, I'm at that height. And at 2 pi, I know that's 1. So if we connect the dots here best I can, it's kind of hard to draw this free-handed on this thing. So here is one period of the cosine curve. Alright. Now in part 2, it wants me to extend this. So let's see, let's take a picture of my graph. And let's move it to problem number 2. Alright, so it says it's an even function, so it's symmetric about the y-axis. So let's change colors here to, I don't know, to green points. So I know that that point is symmetric with itself with respect to the y-axis. This point that went to the right, I'm now going to go over the same distance at the same height to the left. This point is reflected across the y-axis. Here at pi over 2 and at negative pi over 2, it's an x-intercept. Here I've got this one here at 3 pi over 4 and at negative 3 pi over 4. Then at pi it's -1, and at negative pi it's -1. And now I start going up. So I'm here, 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 and then about right there, about there, and there. So if I connect these dots, this is a mirror image of, on the right hand side, what I've sketched out in red. Alright, so there's the graph of the cosine curve from -2 pi to +2 pi. Alright, so here they've done the graphing for me and I just have to read the graph. So for the period, it's the length that on the x-axis that it takes to complete one cycle. And if I start here at the origin and I go up and then I come down and then I go back to pi right here, that's completed one cycle, because now this up and down pattern just continues to repeat. And you can see that if I highlight this in different colors, that period, the distance from 3 pi to 2 pi is 1 pi. So from start here at 0 to this pi minus 0, the x-coordinates, if I take the x-coordinate here, which is pi, and the x-coordinate here, which is 0, pi minus 0 is pi. Now the amplitude, let's draw our center line. Our center line always cuts this wave right in two. As far as it cuts from the max and min, from the range, it cuts it right there in two. So the amplitude is the distance from the center line either up to its max or down to its min. Since it's a distance, we don't use -1, even though it is going down, we just use that distance, and that distance is 1 unit down, just like this distance is 1 unit up. So the amplitude for this graph is 1. Now, this graph passes through the origin, and it's symmetric with respect to the origin. If you rotate it 180 degrees, you get the same graph. This xy, the coordinates of this point, is the opposite of the coordinates here, -x and -y. So this is an odd function. And there's our answers for 3. If we go to 4, let's make this bigger so we can see it. The period, we'll soon realize that just like our horizontal stretches and compressions in a previous skill packet, that this 1/2 is bizarre. It's actually a horizontal stretch by a factor of 2. And let's find this cosine. Let's start here with an x-coordinate of 0, because we're at point 0, 1, and we're going to go all the way here. We go down, we come up, then we come back up to that point. So we've completed one cycle of this. Here's one cycle of this cosine graph, because over here we can see out here to -4 that this, being a mirror image across the y-axis, is another complete cycle. So from 4 pi minus 0, this x-coordinate at this endpoint minus this x-coordinate is my period. So it's a length on this x-axis, which is 4 pi. My amplitude, here's my center line, the x-axis, and my max and min are either 1 unit above that center line or 1 unit below that center line. So the amplitude is a distance. It's always positive. So like I say, if you're thinking 1 unit down, if you're thinking -1, take the absolute value of it because it's a distance, and that's 1. Now here we see that we have symmetry with respect to the y-axis, which is an even function. Alright, so here we have a transformation of the cosine curve. The 3 is a vertical stretch. So let's look at the period. We're starting here at 0, 1, and then to get back one cycle of this to get back up to there is of length 2 pi. 2 pi, the x-coordinate here is 2 pi, the x-coordinate here is 0, and 2 pi minus 0 is 2 pi. That length is 2 pi. Even if you had chosen over here, if you had chosen this guy, you've got -2 pi minus -4 pi. So that's, again, 2 pi. All right, the amplitude. Let's find the center line. The x-axis is still the center line. The amplitude, whether you go 3 units up or you go 3 units down, it's a distance. So if you're thinking -3, take the absolute value of it. Hey, it's +3. And this graph is symmetric with respect to the y-axis, so this is an even function. Here, let's see if we can trace out one complete period of the sine curve. We're starting here at 0. We're going up, and then we come down, and then we come back here, and that x-coordinate right there is 3 pi. This x-coordinate is 0, so this multiplier 3 over 2 changed my period from 2 pi to 3 pi. I still have my center line is the x-axis, and my maximum value is either 4 units up or 4 units below. Amplitude is a distance, so we always use a positive number. This has symmetry with respect to the origin, and it's rotational. So if you rotate this 180 degrees, you're going to get the same graph. So this is an odd function. If you put your pencil on the origin and spin this graph 180 degrees, you're going to get the same graph. Now, because here, let's see how we get the same graph. I rotated it and it's traced out there, or I can I can't rotate it. If I rotate it back, it's just because I'm not able to rotate it like you can. about the origin, I'm spinning it about this thing, so it's not a true 180 degree symmetry. But if I make that shift, you can see that you get the same graph. Alright, so here, let's look at this guy. So my period, where does this pattern begin to repeat? If I start here and go up and then go down and come like this, then the pattern starts to repeat. It goes up and comes down and then goes to there again. So the distance from this x-coordinate to here to this x-coordinate, 2 pi minus 0, this is 2 pi. Or if I started here at 4 pi minus 2 pi, 2 pi. So the period is 2 pi that I'm just inspecting from the graph. Now this time my amplitude, I have to recognize that if I have a maximum of 5 and a minimum of 1, that my center line is here at 3, and my amplitude, either you go 2 units up or 2 units down to go to the maximum or minimum. So this was the amplitude. Now this guy is clearly not symmetric with respect to the y-axis, so it's not even. And odd functions are symmetric with respect to the origin if you rotate them 180 degrees. Well, if I rotate this 180 degrees, the whole graph will be below the x-axis and won't be the same graph. An odd function will always pass through the origin. This doesn't pass through the origin, so the graph of this function, although it does have symmetry, it is not symmetric with respect to the y-axis. It is not symmetric with respect to the origin. So we would say that this graph is neither. Alright, so let's take a look at this one. Now eventually we'll be looking at the equation to determine the period, the amplitude, but now we're just looking at the graph. So the period, if I start here and I make this cycle of going down and then back up again, I can see that pattern repeats. This up and down pattern, the next cycle would go down and then come back up. So the x-coordinate here is 2 pi, the x-coordinate here is pi, and 2 pi minus 1 pi is just pi. And here pi minus 0 is just pi. Now the amplitude, I need to find the center line. If this is negative 5 and 1, then I go up 3, 1, 2, 3. My maximum points are 1, 2, 3 units above there. If you're at negative 2 and you add 3, you'll be at positive 1. Or if you're at negative 2 and you subtract 3, you'll be down here at negative 5. Now, I don't want to represent a distance as a negative 3, so I take an absolute value of that. Or if I just go up 3 units, I recognize the amplitude is 3. This graph is symmetric with respect to the y-axis, so it's an even function. Let's take a look at this guy. So let's pick any starting point. It's just easiest if we pick points close to the origin or down here. And for cosine, if we trace out one cycle that goes up and then comes back to the original right there, you can see that it's that pattern that repeats forever, both to the left and to the right. So here to the left, that up and down pattern is right there. And the distance from this point, the x-coordinate from this point to this point, 3 pi over 2 minus 0, hey, this period is 3 pi over 2. Now let's figure out the center line. I've gone up 5 and down negative 5, so the center line is the x-axis. And the amplitude, whether you go up 5 or you go down 5, has a distance of 5. Down we might use the negative sign as a direction to imply that the negative is down and a positive is up, but when we're talking about distances, we always try to use, we always use positive numbers. There's only rare circumstances in some physics problems that we use a negative distance. All right, this is symmetric with respect to the y-axis. The right-hand side and left-hand side are mirror images of each other. If you were to fold this graph along the y-axis, this right half would fold directly on top of there. This is an even function. Let's make this big so we can see it. Here there's a cosine, but there's been a shift. If I start here at the origin, then I go up, then come down, and then go like that. Here's one cycle of this, and later on we'll recognize that sine and cosine are just a horizontal shift apart from each other. That many people would look at this and say, well, this is the sine curve, it's going through the origin. But in reality, the original graph was cosine, but it did have a shift to the right, pi over 2 units. All right, so the period, the distance on the x-axis that it takes to complete this single cycle, this x-coordinate is 2 pi, this x-coordinate is 0, and 2 pi minus 0 is 2 pi. Even if you took if you took this cycle over here that completes, you know, what does it take to complete one cycle? Negative 2 pi minus negative 2 pi minus negative 4 pi. Boy, this is lagging really bad. That's the same as 4 pi minus 2 pi, which is 2 pi. We already said the distance from here to here is 2 pi. Now, I'm going up 2 and down 2. My center line is the x-axis. And I've mentioned it many times now that we use, I don't know if that's going to let me move that. Well, I'm not on the x-axis very well, but you can see if you go up 2 or down 2 that the amplitude is 2. For even, odd, or neither, I'm going through the origin, and I can see that the coordinates of this point, if you call it x and y, pi over 2 and positive 2, over here are negative x and negative y. That I've got positive pi over 2 and negative pi over 2. The x's are equal and opposite, and the y values are also equal and opposite. This is positive 2 and this is negative 2, and that's true for all the points on this graph. So it's an odd function. If you rotate this 180 degrees, you'll get the same graph. Alright, we're getting near the end here. Boy, this is lagging and it's not cooperating very well. Let's see if we can, well, it might be a little bit awkward for you at first to see, hey, if I start my cycle here where it's kind of up there close to 1, and I come down and I get up here, and when I get up here to this value, see I'm close to 1, here the x-coordinate is 0, here the x-coordinate is 2 pi, so even though this had a shift to the right of pi over 3 units, and originally it was the cosine, that 0, 1 got shifted over here, and this guy is about pi over 3, and we'll learn that in detail later. The x-coordinate here is 2 pi, and the x-coordinate here is 0, and that length to complete that one cycle is 2 pi. Now the amplitude, we can see that the center line is again the x-axis, and 1 unit up and 1 unit below are the max and min, and even though below is a negative value, as far as distance is, it's just 1 unit a directed distance down versus 1 unit directed up. The amplitude is a distance and it's 1. This is not symmetric with respect to the y-axis or the origin. Alright, I'm back. I'm sorry I had to cough again, and so sometimes I can't hit that pause button fast enough. So these are our answers for problem 11, and this might be the last problem. And yeah, it is, because this is the next day's problem homework. Hey, I'll talk to you later. Hope this helps.